All right, this is number 3 from the last acid-base test. The question says you're starting with potassium sorbate, and you know you need to make a known concentration. So you have 45 mils of the stock solution, and you've got a concentration of HCl. So you know the Ka. Net ionic, I'm not going to bother. The next step, though, it says it tells you the amount of HCl that's added, and it asks to get the equivalence. So it's asked for what the concentration of the K of the potassium sorbate is. All right. So you know, again, this is going to be stoich first. You know the 45 mils of the sorbate. Obviously, I'm just going to ignore the potassium because it's a spectator. You know the volume and you know the molarity of the H that's added. You also know that you've titrated to the endpoint. Therefore, you can calculate the moles, or in this case, millimoles of acid, 37 millimoles. If we're at the endpoint, we have 37 millimoles of the potassium sorbate of the base. All right? So, if we know we started with 37 millimoles, these are both canceled out. What are we left with is 37 millimoles of the conjugate acid. Now, the care has to be taken, if you're going to use the Ka expression, the care has to be taken that you use the total volume. So you check the new total volume, you sum up the 29.95 mils that you added to the 45 mils of the stock solution that you started, and you're going to have 74.95 mils. So now you know this concentration. You were given a Kb, but again, no, you're given a Ka for sorbic acid, so you can go directly, if you know the Ka for sorbic acid, and you know this, that sorbic acid is going to break up in small quantities to produce the H pluses and the sorbate ion. And so now you can figure out the pH by simply solving for X and then taking the H concentration and going to the pH. To find the concentration of that solution, pretty simple, because this is letter B. All you need to do is you know that you have 37 millimoles of this in a total mils of 45. There's your concentration of the sorbate. Now, finding the pH at the half equivalence, how are we going to do that? Well, that's really easy, because you know the Ka, and you know that the pKa is equal to the pH at the half equivalence point, because basically the other two are going to cancel out. If you like Henderson-Hasseldoof, you can go with that. And these two are going to cancel. Log of 1 is equal to 0, so that goes away. So you can just take the P of Ka, find the pH. Let's see. Was there anything else challenging in that one? Yeah, the care had to be taken in Part E, because in Part E, you were given the initial pH, you were given the pH at the equivalence point, but they asked to show what it was at the half equivalence point, so you had to make sure that it arrived right on time. All right, if you have any questions, shout out in the notes section below. I'm looking for 40,000 likes.